Hey, this is Jeremy, and today we're going to be talking about acid-base balance. So the big thing about acid-base balance that we need to understand is, to start off with, is acid-base balance is all about your pH. And so what that stands for is the potential for hydrogen. Or you can say your pH is also a measurement of acidity. And that is because hydrogen is going to be considered an acid in this derangement. So what we have is, right here in the center, we have our number one, that's going to be the lowest point of our pH that we're going to have. And up here to the top, that's going to be your 14. That's going to be the highest that our pH is going to go. And if you are closer to number 14 on your acid-base balance, you are going to be considered alkaline. And as far as your body goes, that's going to be considered alkalosis. Now, whenever we get down here to the number 1, the closer we get to number 1, we are going to be considered acidic, or our body's going to be is going to be an acidosis type state. So right here in the center, we have we're going to have the number 7, but that's going to be true neutral. Now our bodies, they are cruising in between 7.35 to 7.45 as far as the pH goes. And so what that is that is slightly alkalotic in comparison to the number 7, which would be considered that true neutral. Okay, so 7.35, 7.45, that is going to be what we want our body to stay at. And so your body has a mechanism of maintaining this balance, and that's going to be your respiratory system and your metabolic system. Over here in your respiratory system, we have our oxygen that we breathe in, and we also have our CO2 that we exhale, or carbon dioxide that we exhale. Your body has to maintain a balance of that oxygen and that CO2, and if there is an imbalance in that, it can kind of cause your respiratory side to become slightly more alkalotic or slightly more acidotic. And the same thing is also true for your metabolic state. If your metabolic state is, you have your bicarbonate buffer right here, so this is our bicarb buffer. You have your bicarbonate buffer, and then you also have your carbonic acid. If I were to have a whole lot of acid, that would lead me to go down on my pH or become slightly more acidic. Okay, and so these are just a couple things that we have to consider in this. And this is your body is maintaining a balance of these, and that's incredibly important. We'll talk more on that here later. So to start off with, on our respiratory side, we have a couple different things. We have our pH, which stands for potential of hydrogen, or measurement of acidity. We have our PO2, and you can look at this as just your O2, which is your oxygen. This P that we see right here in front of oxygen and the CO2, that's going to stand for the partial pressure of oxygen, which is essentially how much gas is dissolved in a liquid. But we can talk about that in a later video. But we have our pH, our oxygen, our carbon dioxide, and our respirations. Our respirations is going to refer to how much gas exchange or how fast we're breathing and kind of what's happening there. So if we have somebody who has a pH of, let's say they increase their oxygen saturations for whatever reason, okay, their oxygen levels are going up, okay, I'm sorry, their oxygen levels are going up. And so what happens is, if my oxygen levels go up, then this is going to mean that my CO2 is going to go down. Now my CO2 is considered an acid, okay, and my O2, my oxygen, that is going to be considered a base. So if I increase in my base and I decrease my acid, what this is going to do is this is going to cause my pH to rise. And what this is likely due to is going to be my respirations have increased because it has allowed me to bring in more oxygen to my body and take more carbon dioxide out. So I'm exhaling more CO2. So this could be due to me breathing fast, me breathing deeper. It could also be due to my oxygen levels in the air increasing. Maybe you have somebody on a nasal cannula or non-air breather. And so this is how that works out. Now, if I have somebody whose CO2 increases, okay, what's going to happen is, again, my CO2 is an acid. So if I have somebody who has a CO2 level that's increased, something that's going to cause that is for your breathing to slow down, such as with an opiates. Okay, so if you have somebody who has an opiate overdose, their respirations have decreased, which is going to cause an increase in their carbon dioxide. And what this is going to do is, if I'm breathing slower, I'm not having as much oxygen available to me, which is going to cause my pH to go down, and I'm going to become in a state of respiratory acidosis. Now, if we have somebody who is having a panic attack, for example, okay, so if we have a panic attack, our respirations have increased. And so what do we know about our respirations increases? Anytime that happens, our oxygen is going to increase, which is therefore going to make our pH increase. And then that's going to mean that my acids are down or my CO2 is down. Now, there is a mnemonic that we can use whenever we're looking at our acid-base balance, and it's called ROME. All right, and so ROME. So what this stands for is respiratory, opposite, and metabolic is going to be equal. And so what this means is that for the respiratory side, it is going to be referring to our pH and our CO2. And as far as our metabolic side, metabolic is going to be referring to our pH and our HCO3. Okay, so what this means is that if my pH on the respiratory side, if my pH goes up, then that means that my CO2 goes down. If my CO2 goes up, then this is always going to mean that my pH goes down. On metabolic equal, if my pH increases for any reason at all, what's going to happen is if my pH increases for any reason at all, then my bicarbonate buffer is also going to increase. Or if my metabolic decreases, my metabolic pH decreases for any reason, then that means that my bicarbonate buffer is going to decrease as well. And we'll be talking about bicarbonate buffer at a later time. So looking at this, what we know is that if I have somebody who, let's say that they overdose on antacids. Okay, so you have somebody who had swallowed an entire bottle of Tums. So what can happen is if they've taken a whole lot of Tums, what's going to happen is their carbonic acid, which is this H2CO3, it is going to get low. And so what this means is if my carbonic acid gets low, then this is going to mean that I have more circulating bicarbonate buffer, which also means that my pH is going to go up. So if I have somebody who overdosed on an antacids, this is going to put them, so antacid overdose, this is going to bring them up. Their pH is going to come up, and it's going to be closer to 14, and that is going to affect their pH by increasing it. Their circulating bicarbonate buffer is going to increase as we have less hydrogen ions, and our H2CO3, which is our carbonic acid, that is going to decrease. Now, if I have somebody who goes into a state of DKA, for example. So DKA is known as diabetic ketoacidosis, and it's essentially whenever your body produces a whole lot of ketones due to your inability to metabolize glucose. and this is going to affect your body in a couple different ways. But as far as your acid-base balance goes, those ketones can be looked at as acidotic. So, and that's going to affect my carbonic acid. So if I've increased my acids, what this means is that I have decreased my pH. And with me decreasing my pH based off this respiratory opposite metabolic equal, this one right here, metabolic equal, if my pH decreases for any reason, then my HCO3 or my bicarbonate buffer is also going to decrease. Okay, so and with all this being the case, there is a balancing act that takes place between your metabolic side and your respiratory side. So if I were to have somebody who were to be vomiting a lot, and they would have nausea, vomiting, diarrhea, they would be losing their acid, stomach acids, and that's going to affect their body's pH. So if I've decreased my acids, what's going to happen is my bicarbonate buffer is going to have increased in proportion, and my pH is going to therefore rise. Now, going back to what I was saying about the balancing act, what happens is any time that your body has something happen on one side, it's going to change what's occurring on the other. So what's going to happen is if I have somebody who does go into they do overdose on an antacid, what's going to happen is we've all played with a seesaw at one point in our lives, where we've seen one on a playground. So in this 7.35, 7.45, we want to maintain a balance. So if you have somebody who is in metabolic alkalosis, there's going to be, again, this right here is going to be the center of our seesaw. And so what's going to happen is if I have my metabolic sides increased, okay, so and then let's say that my pH is going to be we'll say it's 7.6. Okay, what's going to happen is, and don't focus so much on the number as much as the principle. So if I have somebody with a metabolic pH of 7.6, which is pretty drastic, what's going to happen is their respiratory side is going to compensate. It is going to compensate for the copious amount, the pH that's increased over here. Your pH is going to decrease on your respiratory side. And so it's going to do that by potentially slowing down your respirations, causing your carbon dioxide to build up, and you're going to decrease your oxygen. And this is can potentially be a very, very catastrophic event. And so this can lead to somebody having a pH of 7.2. And then what's going to happen is a respiratory pH of 7.2. And here in the middle, they are going to meet right there at 7.4, which is going to fall within the parameters of the acceptable pH, so 7.35 to 7.45. They are compensating. Now, if I have somebody who is in DKA, for example, again, so our pH is going to compensate by my respiratory side is going to be affected by my metabolic side. So if I have somebody who's in DKA, what's going to happen is they're going to be in acidotic state. And so with that being the case, if they have a pH of 7.2, what can happen is they're going to start breathing faster. And as they start breathing faster, they increase their oxygen saturations. And as their oxygen saturations increase, the circulating carbon dioxide, which is an acid, is decreased. And this is therefore going to increase my pH. And so if I have somebody with a pH on the respiratory side of 7.6, again, they're going to be able to balance out right there in the middle of that 7.35 to 7.45 window. And all this is trying to do is just maintain something called homeostasis. Okay, and it's trying to maintain the balance of the body and making sure that your body has an acceptable environment that is conducive for your cells to grow and function and for your normal body functions. And if anything falls outside of these parameters of that 7.35 to 7.45, your body is not going to be able to function in that normal or in that abnormal state. And so this is acid-base balance.